Okay. So the next part is evaluation of LLM generated annotation. So we have we have different benchmarks, and even we can generate the annotations for reasoning tasks using LLM. So how we can evaluate now the generated annotations with some benchmarks. So why we have to focus on evaluation? So everyone wants to build language models, but the main critical part is evaluation. So because everyone wants to build, but evaluation is the sexiest part. Because so if you can evaluate the model, and if you can't measure some of the capabilities of the model, then you can't improve the what are the drawbacks or limitations of a particular model. So if we can measure it, what are the limitations, what are the capabilities of the model, then we can improve the whatever the limitations or reasoning abilities, everything. So yeah, evaluation in LLMs is a minefield. But yeah, so the current ways of LLMs don't work well, but especially for annotating or subjectivity level tasks. So, but evaluation is the tricky part, especially in the part, especially when we are generating annotations with the LLMs itself. So if we can look at the LLM evaluation versus human evaluations, so especially like if you look at models, in models, so like large means like models with extensive parameters, and like the models are trained on large corpora. So we have like scalability and data capabilities. And what does it mean expressive? So the models are expressive. So models are capable of handling complex reasoning tasks, multiple tasks at the same time, and also have instruction capabilities, like how we can ask humans like what is the sentiment of this particular sentence? Can you summarize it? Can you describe it? So we can also like the current large language models have these expressive capabilities like instructions. And also open-ended tasks. So it also deals with all the open-ended tasks, like different users are communicating in the real-time environment, and how models evaluate like the level of chat assistance in real world. So if we look at the models, large language models have all these capabilities like multitask, instruction, open-ended, larger models, more parameters, and data capabilities. Whereas if you take a human level evaluation, so humans are more like understanding. So like in human level, so humans try to understand what the task, and also so there are some dominant measurement errors, like humans also can make mistakes. So if humans they not evaluated the results properly, that result in errors in the models itself. So human evaluation is very critical, so the human judgments makes the models more accurate. So in terms of evaluation, so like especially if you look at large language models evaluation, so it's a resource intensive, especially for large and multitask models. So and the sensitive language models are more sensitive because evaluations may be influenced by specific instruction method. So if we train the model with one domain specific data, then the model is influenced with that particular domain. Subjective, so evaluation of open-ended tasks can be influenced by personal interpretation. So suppose, especially the Reddit data, if we take in Reddit data, users always interacting on certain topics, and these are all more subjective topics. Suppose if we take a abortion topic and multiple users are taking a debate about abortion topic, and these are all personal interpretations. So every user have their own interpretation towards the abortion, and also it depends on the region, even locality and demographic details also crucial role here. Potentially misleading. So human level models can introduce significant measurement errors or biased evaluations, leading to potentially misleading conclusions. So if humans are biased towards their evaluations, that overall reflect in the model level evaluations and potentially misleading some conclusions. So, there are some discrepancies between LLM level evaluation and model level evaluation. Now we can see what are the different ways of benchmarks available. So human preference benchmarks with reasoning tasks. Why human preference benchmarks? So existing NLP benchmarks fails to accurate evaluate LLM chat assistance. So for example, what are the existing NLP benchmarks like MMLU? It's a massively multitask language understanding task, but these are not open-ended. So not what is meant by open-ended or not open-ended. So not open-ended means they are not evaluating the model on the real world data. So where in the real world, directly multiple users are interacting. Suppose if you build a language model and if you want to evaluate on open-ended task, take the model and predict something and give that particular predictions to real world users and ask them to evaluate it. So it's like a real world evaluation, not just like you have some task and some labels and take the model and predict the whatever the labels on the existing task and compare the accuracy. So this is not a open-ended way of evaluation. Instruction benchmarks, so supernatural instructions, but only one turn. So there are some instruction benchmarks which are real world, but only one turn. So like every user only provide one response, and here the problem is human annotation efforts. So we need multiple humans to evaluate whether how the user is providing the response. This is only one turn. One turn means only one conversation or user only talking with the LLM, not multiple users are talking with the LLM. Conversational benchmarks, there are conversational benchmarks which are available, but these are too easy benchmarks, and every LLM can get a state-of-the-art results on the conversational benchmarks. So how to construct a benchmark which consists of real world multi-turn conversations. So how we can take the large language model and which interacts with real world users so that we can evaluate the model much better manner, and how we can automatically evaluate these model responses. So there are 4 popular benchmarks are there, human preference benchmarks. So one is MT bench. So I already discussed in the before coffee break. So MT bench, so where multiple users are talking each other with the LLM, and now the LLM have to judge which user response is better. So MT bench, so challenging multi-turn questions. So you have a sample question. So writing is the first category. So first turn, compose an engaging travel blog post about a recent trip to Hawaii, highlighting calculate cultural experience and multi-sea attractions. Now the user have to write his response for this particular first turn. Now we will get a second turn. Rewrite your previous response. Start everything, every sentence with a letter A. So now we need to write again the sentence with the letter A. So here, so different users participants in the conversation, and we have multiple turns, and the model judge overall that which response is much better. Similarly for math, like we have arithmetic reasoning. So first turn, given that f of x equal to this, find the value of f of 2. So now the second turn, find x such that f of x equal to 0. So there are multiple turns, and so users keep on answering or participating in this discussion. So chatbot arena, so this I already discussed. Chatbot arena where we have 2 independent models, and we don't know what those models are, and user always asks some query to these models, and every model will provide some response. Now the user have to check which answer is better, like if A is better or whether B is better or tie. So based on the user responses, they rank the models, that which models are really good. So then we have MT bench 101 and human eval. So MT bench 101 is even they improved on the MT bench, and human eval I already discussed about human eval, where it's more about checking the model's code generation capabilities. So LLM Judge provides not only score, but also explanations, offering interpretable outputs and valuable insights. So when LLM act as a judge, it not only just to provide the score for a user, but also they provide why this particular response is better. They also provide the reason for that. So how LLM works as a judge? So we have a question, write a travel blog post about Hawaii. So now, so like here, either users can write the responses or even LLMs can write responses. So model A provided some answer and model B provided as some response. Now, which model response is better? So now again, LLM only acts as a judge here. So which LLM acts as a judge here? All the closed source models like GPT-4, GPT 3.5 or Claude. So judgment, I think A provides better answer, therefore A is better. So it is scalable and explainable. So the advantage is, so since there are no humans here, so like all LLMs are acting as a judge. So the like we can scale n number of examples, and it is time, like within the time constraints we can do that, and it is also cost effective. So the agreement between overall GPT-4 judges and human reaches over 80%, the same level of agreement among humans. So overall, when they use LLM as a judge and when they compare with humans, so the agreement almost matches with humans, like around 80%. So the same level of agreement among humans. So even among humans also 80% agreement, and the GPT-4 also have the similar level of agreement with the humans. So, but what are the some limitations if we consider LLM as a judge? So one is positional bias. So LLMs always favor the answer in the first position. So most of the time, LLMs always favor the first position. It is because it is also due to the long context issues. So when a person starting hearing longer story, so normally humans pay attention to the early conversation and they lost in the middle of the conversation. So this is even their problem in the LLM. So there is a awesome paper on LLMs like lost in the middle. So even LLMs also lost the context in the middle of the longer context. So they always favors answer in the first position. Verbosity bias, so LLMs favor longer answers. So suppose if you provide, if you give two answers and one answer is a long answer and one answer is a short answer, so LLMs always favor longer answers as a judge. So self-appreciation bias. So sometimes if the answer is, if the generated answer is pretty similar to the what that model also generated, so LLM answer favors its own answers of answers similar to its own answer. So like it's self-appreciation. So it always appreciate its own answer compared to the other model's answers. So limited reasoning ability. So yeah, so like some LLMs, even they like hard to judge the like a complex math or reasoning or code questions. So it is crucial so to acknowledge all these limitations of LLM as a judge, such as like so the model need to detect the hallucinations, like whether the generated answers are actual, factual or misinformation, and also the LLM as a judge, it need to penalize the LLM generated answers accordingly. So because it need to penalize all the potential errors when grading math or reasoning questions. So if you look at the human preference benchmarks, especially the MT bench 101, so in MT bench 101, they further improved the human chat assistants. Like so, they try to focus on the abilities like context memory and whether the users are understanding the context, and anaphora resolution and topic shift. Suppose if we are talking something and suddenly we shift the topic, whether humans are able to switch the topics, and again they provide a better context. So suppose user one, I want to buy a new laptop for my graphic design work. Another user, my budget is under 1500s. Then considering my budget and requirements, which one should be better? So this is like basically we need to understand the context. We need to understand what is going on and who are talking. And sometimes they shift the topic. So how LLMs understand this? Adaptability. So like content format rephrasing. So sometimes how can quantum computing change the world? So if you ask, can you rewrite the explanation in simple terms? So then the model need to provide in the rephrased manner or simple manner. Multi-turn reasoning. So can you explain it clearly why you provide this answer? Then the model have to provide in the bullet points that these are the reasoning steps I followed and to reach the final conclusion. Interactivity, so like questioning, clarification. So even so if the LLM don't understand what you're asking, so LLM need to ask, could you please rephrase it, or could you provide more details, or could you please provide more context to better understand or better provide your answers. So overall, so when they consider empty bench 101, because now they come up with more capabilities in the data set or benchmarks. So, and when they evaluate on the LLM, so the agreement between GPT-4 and human expert evaluation even reached 87%. So in the empty bench, the evaluation is up to 80% match, whereas on the empty bench 101, the agreement even improved like 7%. So like 87% utilizing the desired evaluation approach. So, so if you can look at the like the hierarchical ability taxonomy, so they mainly focused on the three-level abilities. One is adaptability, perceptivity, and interactivity. How good these LLMs are interacting with you, and adaptability. So if you can ask rephrasing it, if you ask reasoning, if you ask reflection, so it need to self-correct itself. And so suppose if it provide a wrong formation of sentence, and if you ask to rephrase it, it have to rephrase the sentence again in a correct manner. So these are the 13 tasks which are present in the empty bench 101. So they focused on the context memory, then also topic shift, content confusion. Then also we have self-correction, mathematical reasoning, general reasoning, instruction clarification, or proactive interaction. So overall, so on the empty bench 101, so they use GPT-4 to construct this data. So you can see whatever the data they constructed here, they use GPT-4 model to construct all this data, and it is most powerful model for multi-turn dialogue. So where multiple users are talking, and GPT-4 evaluated all these responses. Now, if we can look at each language model's performance on these 13 tasks, so overall, so closed source models are always consistently exhibit superior performance compared to open source models across all tasks. Overall, if you look at GPT-4, GPT 3.5, so these models are always doing much better compared to the open source models like LLaMa or like Chat LLM or Mistral models, or like we have Ultra LLM, LLaMA. These are all open source models, whereas closed source models are always having better performance. Also, tasks like content confusion and format rephrasing are relatively less difficult, because if you can look at rephrasing or content confusion, so every model reached good performance. If we have the 1 to 10, so every model is always have a good performance for the content confusion and rephrasing. Whereas if we take the mathematical reasoning task like MR, so in mathematical reasoning task, open source models, the performance is poorer. Whereas if we take the closed source models like GPT-4, the performance is much better. So here overall, so yeah, closed source models are performing much better, even on the multi-turn conversations compared to the open source models, and also in terms of reasoning abilities. Okay, so how to scale human evaluation? So if we can use large language models as a agent, LLM based agent. So normally like this is what I discussed about chatbot arena, because suppose if you have many responses, and if you want to evaluate those responses with humans, it is impossible, because the LLM is generating millions of examples or billions of examples, and we need so many people to evaluate those responses. So that is why they have come up with the idea of chatbot arena platform, where the user have to just provide which answer is better, and they just need to tick that this particular answer is better. So that is how they rank the model responses. So question, how can improve my time management skills? So this is the one LLM provide one answer and another LLM provide another answer. So if we have only single agent, so like we just carefully reviewing the response for the so the assistant is better. Whereas if we have multi-agent debate, so we have multiple users now providing, okay, this because it is just an online platform. So multiple users will always provide which answer is better. So like multiple users in the debating, and after discussing thoroughly with coworkers, we convinced that assistant 2 is better than the based on the reason. So this is a multi-agent based approach, and we can scale it to n number of people. So chatbot arena, so this is the platform. So they allow users to vote for the superior response manually, which leverage multiple LLMs to autonomously determine which response to stands out. So whenever you create a data set with LLMs, so what you can do, like, so you can use the LLM generated response, and you can, again, if you use two LLMs and we want to evaluate that which LLM generated a response is better, so just use chatbot arena platform and the models, then they have the n number of people, the people vote the, so which response is superior. So this is how you even evaluated with the humans as well. Okay, so this is the human level evaluation because the LLMs are generating and humans are responding. What about LLM evaluation? So here now the LLM is judging here. So if you want to evaluate with the LLM, so for every LLM, you need to create a system prompt. So system prompt is all about the guidelines you can make when you annotate the data. So like what is the task, and what are the steps you need to follow, and what are the guidelines. So provide some definitions because the model need to understand what are the guidelines, what are the objectives, and what are the tasks. And the system format, in which format you will provide the data. So whether it's in the form of JSON format or in the CSV format, you need to provide some system format. And hyperparameters are like, this is already Manish discussed, like what is the context length, and the total number of tokens. Also there is a temperature parameters, that every time whether the model generate random outputs or always model generate the same output. So, and for the benchmarking LLM, so you can use the zero shot, one shot, or few shot, and you can also prepare an instruction that there is some template for the instruction and what kind of task you want to solve. So whether it's arithmetic reasoning, common sense reasoning, or something, and you can also use some data set of some examples, and finally there should be some metric to evaluate that. So overall aggregation of all this will provide a LLM benchmark. So short, like the model is given with or without any prior examples at inference time. So whether it's a zero shot, no examples, like if it is a one shot or few shot, provide with some examples. Instruction, evaluate the model ability to perform any unseen task given context in the form of instruction. So like if we have a model, just to give an instruction, let's say summarize. Summarize is just an instruction. So the model never have seen this kind of task, but still we can evaluate the model. Task, what is the concrete problem that we want to address, like common sense reasoning or summarization or classification. What is your task? Dataset, what dataset we want to use, because let's say if you want to annotate something with LLMs, so maybe you can use some examples from the existing dataset like arithmetic reasoning. So like what dataset you want to use? Metric, so how we can evaluate the final generated responses. So if you have a model with the system prompt, and this is how the prompt look like. So system, so you are a helpful model. Here you provide all the guidelines, what it have to do. And system format, like as I mentioned, in which format you provide the data. So instruction, translate this sentence to French. User, I like pizza. Assistant, Emma, Jamie la pizza. So it is just like so the format you need to provide the input. So this is an example. So then the model you need to provide always data in this particular format, and the model provide the answer. And these are the parameters like temperature. So like how many times the model always provide the correct output, or like whether it provide different words. So repetition penalty, and like it is having vocabulary, some top 50 words, it always pick the words. And after like generating the 1000 words, then it will truncate the generation. So it is like max sequence length. So this is how we can evaluate with LLM. So whenever you want to evaluate the LLM, so you need to follow these guidelines. You need to create a system prompt, you need to create the format, and you need to define the parameters. And with that, we can evaluate the generated data. So there are some tools which are available for LLM evaluation. So one is Alpaca. So Alpaca is an LLM-based automated evaluation matrix. So how Alpaca works? So they take a GPT-3 model, and so they have manually, so they self-created some instructions. So these are like 805 instructions. These are which are having a good interaction with the user. So these are the self-generated instructions. And after generating the self-generated instructions, again, they take these instructions and they fine tune with the any language model, and finally they evaluate it. So here GPT-4 is the evaluation finally they use, and for the instructions, they use any open source language models. So if you can look at multi-turn conversations where GPT-4 is reaching 63%, LLaMa is 55, whereas human versus human is 67. Overall, in multi-turn conversations, GPT-4 is closer to the human level agreement. Even on the multi-turn conversation excluding ties and errors, even GPT-4 is closer to the human level performance. Overall, so GPT-4 its evaluation of chat bot agrees with the human evaluation, and also surprisingly, so LLaMa 2 can compete with the GPT-4 judge, but LLaMa 2 is more biased and less capable, following the instructions carefully. So there is also another evaluation is G-eval. So G-eval is like so GPT-4 evaluation. So can we rely on LLMs to assess the LLM outputs? So do LLMs really show any bias towards the output generated by these LLMs during evaluation? So what they did, so they created a task. So this is about task instruction. What is the evaluation criteria? So like you need to provide some rating. So during the generation itself, the model need to provide some criteria 1 to 5. And what are the evaluation steps? Like if you see now the model is following the chain of thought reasoning, so for the generated content. So this is the input context, target, and the model need to provide what are the evaluation steps it follow, and finally generate the response. So overall, again, so when they use GEval, so human summary and GPT 3.5 summary, which is pretty closer here, human summary is much better. Here, LLM summary is much better, and sometimes even equally good. So overall, GPT-4 or GPT 3.5 are closer to the human level performance on at least some level tasks. So yeah, LLMs are consistently gives higher score to GPT-5, GPT 3.5. So even though human judges prefer summaries written in human language. So there is a other benchmark GPT scores. This also follows same aspect like task specification, template, demonstration templates, and with a different relevant summary. And finally, the GPT score will provide what is the overall score and also what is the inference score. So it also provide the overall relation score and also the inference score, that what is the reasoning capability. So 0.8 time. So finally, the language model written explanation. So we also like there are papers like language models are generating the content and it also evaluating the written content. So like so the written content on the political cues, NLP research, and also philosophy. So on the different kinds of tasks, like different domains. So can generate the written evaluations on political, NLP, or philosophical questions. And with the increase of parameters, the models reach human level performance here. So overall, if you can look at the generated versus original outputs, so the line is clearly fitting on the generated data versus original data. So the line is clearly fitting here. So overall, so using again, so here they use LLMs, they generated around 154 data sets, and they even they discover some new cases of inverse scaling when LLMs get worse with the size. So overall, LLM generated evaluations are very high quality, and they quickly discover any novel language model behaviors as well. Yeah. So that's it from my side. So now I'm going to hand over to Mounika. So Mounika will take care of the next finals.